So now we would like to actually do 11.5 number 37 instead of 25, which is the last one. You might want to edit this part out. This chatting is not great, but change the name on the last video. Okay, great. So let's do 11.5 number 37, which is, I've got, nastiness, right? Okay. I should identify a log rule to use, right? See any? Christian, you got one? Is it division? Okay, so which part of this are you looking at to say?
First, distributing all that.
So you're looking at
into all that. I was wondering, does 1/3 go and then make like the 2x plus 7 and the 7x plus 1 like cube roots?
Yeah, okay, so there's two options here. One is I could distribute this multiplication out, right? Okay, so if I was going to do that, I'd get 1/3 of log of 2x plus 7 plus 1/3 of log of 7x plus 1, right? There's your distribute step. And then you wanted to make them cubed roots, right?
I mean, same thing right there.
Yeah, this really is the same thing as if I pull these up into the exponents, right? So I'll have log of what? No, this is a good idea.
Okay, cube root of 2x plus 7.
Okay, so I get the cube root of 2x plus 7
Plus log of
cube root of
7x plus 1.
Cube root of 7x plus 1. Okay, then there's a rule that tells me something is the sum of the logs, right?
Yeah.
What is it?
You multiply them?
Yeah, so I could say, okay, well, the sum of logs is the log of the product of the two things, right? So that's me thinking about
So we use
this rule, right? Log of A plus log of B is log of A times B, right? Okay, so this would be ln of what?
So can we use the cube root or the cube root roll as well and put it all together?
Yeah, so let's put it.
Distribute it all together, so like 7x.
14x.
Whoa, slow up. Yeah, we could,
Okay.
but I want to write something easy down first.
Okay, so we just put
So
2x plus 7 in parentheses inside there. Or,
sorry, I'm not going to do that yet.
okay.
So first things first, it's just, I've got log of some stuff plus log of some other stuff, right? So I could use my log rule to say, okay, that's the log of this stuff times that stuff, right? Okay, and then we can get crazy with this. We can say, okay, I'm cube rooting all that stuff, right? So we can do this as the log of the cube root of 2x plus 7 times 7x plus 1, right? And then we could,
Make it really crazy.
yeah, we could FOIL this stuff out. I can't say I'd recommend it. You guys see that? Please notice that we use those rules as the exponent rule and then use the sum rule, right? You guys see that? We could have used the sum rule right here and then use the exponent rule afterwards, and we would get to this same spot. You guys see that? So I don't care which way you do this. Both approaches are equally valid, and probably it's just going to depend on which one you see first.
But you don't want 14x squared plus 51x plus 7.
I would probably advise against multiplying this out, but that's a personal preference. The reason I would advise against multiplying it out is that it's easier to multiply it out than it is to factor it back, right? So if for some reason I need this, right? This is the kind of lower energy form to have it in, because if I need it multiplied out, it's easy. If I multiply it out and then forget about this, it's hard for me to get back to this. You guys see that? This is just a what are you going to do with it later kind of thing.
So, my question is, what
Mhm.
did the directions for that set in the book say?
Yeah, so the directions for this in the book say simplify to a single logarithm with a coefficient of 1. So if we had used the product rule to combine these into, so if we had said this is a third of log of 2x plus 7 times 7x plus 1.
Would be wrong because we don't have coefficient.
Yeah, here we've got a logarithm, right? A single logarithm, but we have a coefficient of a third instead of 1. So we'd have to use the power rule to drag that up, and we'd end up at the same place. That's cool. And I'm not going to be super picky. If you write this as log of stuff to the 1/3, I'm okay with that. You guys cool?